August 1942, Henderson Field, Guadalcanal, Solomon Islands. The air is thick, hot, and heavy with the smell of swamp, sweat, and burning aviation fuel. The silence is short-lived, broken instantly by the roar of an F-4F Wildcat taking off, its engine strained by the oppressive humidity. On the edge of the hastily cleared Henderson Field, Sergeant Frank "Brick" Riley wipes the red dust from his face and squints at the sky. He isn't a pilot or a medic, he's a construction engineer, and he's watching the very edge of the Allied counteroffensive break apart. Guadalcanal is hell. It's the first foothold against the relentless Japanese expansion. But victory depends not on courage alone, but on a thin, perpetually patched runway. Every time a Japanese bomber raid hits or the monsoon rains turn the surface to soup, the field becomes unusable. Planes are grounded, pilots wait, helpless. The battle for Guadalcanal is, at its core, a battle for this single strip of earth. Across the globe, the problem is the same. The pace of the war is dictated by the pace of construction. In the Pacific, the advance relies on island hopping, each newly secured island demanding a fully operational bomber base yesterday. In North Africa and soon in Europe, vast theaters of operation require massive concrete airfields to base the thousands of fighters and bombers of the USAAF and RAF. But building a runway is agonizingly slow. The standard process for laying heavy-duty concrete capable of handling fully laden B-17 Flying Fortresses or B-24 Liberators involves precise mixing, meticulous pouring, and, most crucially, a lengthy curing time that could take weeks, sometimes months, before the surface achieved the necessary compressive strength. Frank Riley knows the timeline. Take the beach, clear the jungle, and then wait. Wait for the heavy machinery to arrive, wait for the materials to be mixed, and then wait for the concrete to harden. In a war measured by days, those waiting periods were bottlenecks where ground forces were exposed and air cover was critically absent. The logistical tail of Allied air power was too long. It stretched back across oceans, and it was held up by the chemistry of cement. Meanwhile, back in the relatively comfortable environment of the U.S. Army Corps of Engineers planning offices, the military mindset prioritized durability, precision, and adherence to established engineering standards. The assumption was simple. Building a permanent, heavy-duty concrete runway must take months. They believed any attempt to rush the process would result in a fragile, dangerous surface that would crumble under the first landing. Enter George C. Splane. Splane wasn't a grizzled military engineer. He was a civilian contractor and construction expert from the American Midwest, a man who understood how to build quickly and efficiently in the civilian world of roads and factories. He was brought in to advise the military on how to expedite their construction efforts, and he saw the flaw not in the chemistry of the cement, but in the methodology of the military. To Splane, the runway construction site was operating like an ancient craftsman's workshop, a bespoke process built around waiting. The military would pour a large section, then move the entire workforce and all their machinery to wait while it cured. They were building airfields one large, slow, stationary block at a time. Splane saw it differently. Why stop the process? Why not apply the assembly line principle, the very same innovation that was allowing Ford and General Motors to churn out tanks and planes, to the ground they landed on? He proposed a system that seemed impossible to the military engineers. It required innovation in two critical areas, process and material science. He demanded the adoption of a rapid-setting cement mixture capable of achieving runway-ready strength in a matter of days, not weeks. And he designed a radical new construction system that kept the entire line, the earth movers, the mixers, the pourers, the finishers, and the curing crews, moving forward continuously, never stopping, never waiting for the previous section to set. The military engineers, steeped in tradition, initially laughed at the idea. Pouring high-quality, durable concrete in an assembly line fashion in harsh battlefield conditions and having it ready for bombers in just a few days? It was a fantasy. It violated every established principle of heavy engineering. But the strategic clock was ticking, and the losses at places like Guadalcanal demanded a miracle. They gave the civilian contractor his chance. Splane was about to take a civilian idea and revolutionize the pace of global warfare.
The testing grounds for George C. Splane's impossible method were initially in the familiar, controlled environment of the American Southwest, but his techniques were soon deployed to the chaotic, wet, and often enemy-threatened theaters of war. The core of his innovation wasn't a single machine, but a continuously moving operational doctrine that treated the runway like a product on a belt. Splane introduced specialized, highly mobile equipment that could operate in tandem. The process looked less like construction and more like a precision military drill. Preparation squads. Ahead of the line, giant earth-moving equipment, the scrappers, graders, and compactors, prepared the subbase with incredible speed, ensuring the foundation was uniform and stable. Mixing and delivery. Instead of batch mixing, Splane mandated a constant stream of rapid-set concrete, often using locally sourced aggregates and specialized high early-strength cement additives. This material was delivered to the point of pour via a synchronized fleet of trucks, eliminating downtime. The paver train, the most visually stunning component, was the train of specialized concrete pavers and finishing machines. These machines were massive, self-propelled platforms that moved slowly and steadily forward. The concrete was poured into a continuous formwork between the machines and immediately smoothed, vibrated, and shaped. The precision was still there, but the weighting was eliminated. Curing on the move, finally, behind the finisher, crews immediately covered the fresh concrete with curing compounds, often a chemical membrane, to ensure rapid, consistent hydration and hardening. Because the concrete mixture itself was designed for high early strength, the pavement was ready for light traffic within 3 to 4 days and heavy bomber loads within a week. This efficiency was a direct result of Splane's civilian experience. He had recognized that the greatest waste of time was the non-productive hours where equipment and manpower sat idle. By standardizing the process and keeping the line moving, he was able to complete sections of runway 50 feet wide and several thousand feet long in a fraction of the military's projected time. The concept of building airbases in weeks instead of months was suddenly a logistical reality. The impact was felt immediately in the Allied advance across North Africa and, most spectacularly, in the preparation for the D-Day landings, Operation Overlord. The massive buildup of air power in the United Kingdom required dozens of new heavy-duty airfields. Splane's methods, adopted across the U.S. Army Corps of Engineers, allowed the Allies to build and expand airbases like RAF Greenham Common and RAF Thurley at an unprecedented tempo. For the American Air Forces, which relied on overwhelming numbers, this meant the difference between sending small, tentative bomber strikes and launching the 1,000 plane raids that ultimately crushed the Luftwaffe and shattered Germany's industrial base. Every day Splane shaved off construction time translated directly into more fully fueled B-17s ready to fly over the Reich. The system wasn't easy. It demanded brutal labor, strict adherence to the moving schedule, and the constant threat of enemy action. But by placing civilian ingenuity at the forefront of military necessity, George C. Splane didn't just build runways faster. He fundamentally changed the logistical clock of the Western Allies, transforming their industrial output from mere material strength into an applied speed that the Axis powers could never counter. The Allied air superiority was not only about having more planes, but having more places to put them faster. The concrete miracle was, in its own quiet way, one of the most critical turning points of the war.
Splane's innovation was critical, but it was just one piece of a broader revolutionary shift in military construction known as advanced base construction. It involved not only concrete, but also the massive, coordinated effort to deploy entire prefabricated infrastructure sets, like the famous Marston Mat or PSP, perforated steel planking
for temporary runways. However, for permanent, heavy-duty bomber bases, the Splane method of rapid-cure, continuous-pour concrete was essential. Consider the Pacific. After securing an island like Guam or Tinian, the Allies immediately needed air bases to launch the massive B-29 superfortresses for the final assault on the Japanese home islands. These bases were gargantuan undertakings, requiring runways capable of supporting a 60-ton aircraft and continuous operations. Military engineers had estimated it would take 6 to 8 months for each base. Utilizing Splane's high-speed paving techniques, the vast airfields necessary to launch the strategic bombing campaign against Japan were often operational in less than 3 months. This speed had a direct and crushing strategic effect. It denied the Japanese time to consolidate their defenses, forcing them to fight almost immediately after an island fell. It meant that the gap between taking an objective and making use of that objective for the next leap forward was drastically shortened. The pace of the war, measured in logistical miles and production hours, was now accelerating beyond anything the Axis powers could conceive, let alone match. The lesson of George C. Splane's impossible trick wasn't a lesson in firepower, but a profound demonstration of the synergy between civilian industrial efficiency and military necessity. A war is won not just by those who design weapons, but by those who can rapidly deploy the infrastructure to support them. Splane's methods became the foundation for all modern military and civilian heavy construction, a permanent legacy born from the urgency of global conflict. The unassuming civilian engineer proved to the world that when American industrial spirit was unleashed, not just to build machines, but to solve problems of process and time, the resulting acceleration was a force far more destructive to the enemy's plans than any single weapon. The thousands of tons of bombs dropped by Allied aircraft were simply the final expression of a logistical victory won weeks earlier by a relentless, continuously moving concrete paver train.